Hello everyone! Welcome to Universe Sandbox 2. You know, I really like this game. You know why? Because I like space. Because space is cool, as Markiplier once said. Alrighty, so, um, hmm. You know, I don't actually have much of a plan for this video. So, what we're gonna do is just play around in the Universe Sandbox. Alrighty, so what we're gonna do first is, make the Earth zero point 0.5 suns. But hold on. Oh, alrighty. So now the Earth is black. Alright, that's a little weird. Alright, let's see what happens to the solar system. Let's just speed it up a little. Ooh, alright, so Mercury is not having a fun time. And the Sun is also not having a very pleasant time. Alright, so, oh no, everything's getting thrown off orbit. Oh no. The solar system's in disarray now between the Sun and the Earth. Doesn't look like my computer is really liking this. Oh no. There goes Mercury. Wow. Alrighty. Man. Alright, let's just get the solar system back. That's where we're gonna I'm just gonna start a whole new simulation. We're gonna be able to do whatever we want in here. Alright, so let's see what we want first. Let's do let's do a random star. Let's see what this is. Ooh, it's blue. Oh. See, just look at this. I love this game. Like, just see how nice this looks. Like, wow. Alrighty. So what we're gonna do with this is just launch a gas giant into it. Nope. Alright, this may take a little bit. It's like an asteroid, but it's a whole planet. It's 3.4 times the size of the Earth. Oh my goodness. Alright, slow this down. Oh. Okay, let's slow this down even more, so we can just get a really nice shot. Oh my gosh. It's just depositing all of its material into the star. Wow. There it goes. And it's gone. Wow. What happens if we do a pulse? I've never actually tried this. Boop. Oh. Oh. It's just pulse of particles. Alright, that's cool. Fireworks? No? Okay. Let's launch. You can hear it. You can hear the rumbling of the star. Sounds really cool. Let's launch the few moons into this thing. That's always fun, right? There we go. Whoa. It actually made lasting impacts on the star. It's interesting. Even the gas giant didn't do that. You know, the scales in this game are just really amazing. Because just look at this. Let's just put the Earth right here. Look at this. This is the Earth compared to the star. This is amazing. And all of the land masses on Earth are covered with water. And it got swallowed by the star. Dang. Alright, so this star has been doing very well with just taking down all of these things. But what can it do against something 100 times the mass of the sun? That was a bit too quick, evidently. Let's just intercept him. Alrighty. So what happens now? It is having a not fun time. You know, I just kind of want to talk a little bit. You know? This is Sagittarius A, and is the black hole at the center of our galaxy. It is, what is that? 100, it's that 4.3 million times the mass of our sun. And it's only 18.3 times the radius of the sun. See, black holes are one of the most fascinating objects in our universe. They are the result of just gravity taking over an entire object, just everything about an object. If space-time was a sheet, then a black hole would represent an endless hole in space-time. That's why it's called a black hole. It's a hole in space-time, and the gravity is so strong at the event horizon that no light can escape. Light is the fastest thing in the universe, so nothing can escape it after anything passes its event horizon. What's also really interesting is I'm not sure if it'll be shown in this game. I would assume not, because it's a really, really cool concept. Well, what I'm hoping it would represent is Hawking radiation. Now, what Hawking radiation is actually very interesting. In the oh, okay. Alright, looks like the game didn't like that. Okay. So what Hawking radiation is, in all parts of the universe, virtual particles are popping into and out of existence, a particle and an antiparticle, and annihilating each other. This happens in all regions of the universe, and we call this vacuum energy, I believe. I believe all of this. You may want to fact check this, but to my current knowledge, this is what I think it is from reading. So, this vacuum energy, right? It is in all regions of the universe, and even at the very, very border of the event horizon of a black hole. Now, the event horizon of a black hole isn't some boundary. It is like imaginary. It is something that mathematically exists, not physically. So, these virtual particles can pop into existence inside the event horizon and outside the event horizon. One can pop inside, one can pop outside. And so, like we said, nothing can escape the event horizon of a black hole. So one particle will go into the black hole, and another one will be jettisoned out into space. And this is what is called Hawking radiation, just emissions from a black hole. And it can take timescales that are in the exponents of years. For example, some of the biggest black holes that we know of in the universe will take approximately 10 to the power of 100 years to disintegrate as a result of Hawking radiation. And this is incomprehensible. It's ridiculous. So, it's very cool, because 13.7 billion years is pretty much nothing compared to the lifespan of a black hole. So, that was my rant for this video. So what else are we gonna do? Let's just take the Earth. The little Earth. How you doing, bud? Oh, hold on. I kind of want to send something into the United States, because everyone knows that's the only place where aliens land. Now let's just send it right in the center. There we go. There you go, bud. Let's just send a few more. Boop, boop, boop. I'm surprised there are still lights on in the United States. Even as, we're just literally just destroying the entire thing and covering it in craters and lava fields. I find that fascinating. Oh wait, it's cooling off. Hold on. Let's just bombard them. There we go. Oh my goodness. Wow. Alright, let's do that again. That was fun. Boop 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 boop. There you go. See, isn't that fun? What's the stats of the TARDIS? Oh, that was kind of sad. Alright, let's put a pumpkin, or let's put a jack-o'-lantern actually, just right over, well, let's put it 1 AU away, and you'll see why in a moment. There we go. Now we are going to expand this thing to 1 times the mass of the sun. There you go. Very nice. How many Earths is this? Oh my, 178. What is the Earth doing? Oh, goodbye Earth. Alright, let's try that again. Hopefully we'll be more successful this time. Alright, so we are going to do the same thing with a jack-o'-lantern. Jack-o'-lantern US, of course. Oh my, that was a bad voice crack. Alright, so, US squared? Huh, interesting. Actually, that would be technically be U times S squared. So, sorry about that. Alright, so, we have it 1 times the mass of the sun. Let's see what the Earth looks like. Oh my. Alright, let's put them at 1 AU away. I love the music in this game. It's very peaceful. Hold on, let's just delete this Earth right here. Sorry, bud. You are the weakest link. Goodbye. Alrighty. Let's look at this. And it's rotating perfectly like it would around the sun. Because it doesn't matter the light or the luminosity or any energy coming from an object. All that matters in an orbit is the mass of the object. So, if something has the exact same amount of mass as an object, it will have the same exact orbital period and radius of orbit. Put it at 1 year second. So it goes around once every second, approximately. I love space. Space is one of my favorite things. Alrighty, so, what should we do next? Well, let's take this Proxima b. I actually just learned about this. Proxima b is the nearest Earth-like planet to Earth. It is in the Proxima system, about 4.6 light years away. And it is orbiting Proxima Centauri, I believe. But this is hopefully one of the things we hope to get more data out of in the Breakthrough Starshot project. Now, what Breakthrough Starshot is a project where these little probes, basically just grams in weight, they get sent out and they have solar sails attached to them, just much, much, much bigger than themselves. And what we'll do is on Earth, we will have lasers shooting at these sails. And what this will do is actually propel the drones very, very, very quickly to 20% the speed of light, which is approximately 60,000 kilometers per second. And so, this would take about 20 years to get to the Centauri system. Although the technology isn't really a thing yet, because if you're getting accelerated to 20% the speed of light, you're gonna need some hardiness, or you're gonna get torn apart. Also, we need to figure out a specific trajectory, because if you are traveling at 20% the speed of light, and you're weighing in at grams, then any little pebble floating around in space is going to tear you apart instantly. So, we still have to develop new technology and new systems in order to do this. So, that is a problem, and will take, conservatively, 20 years to accomplish. So, and it will take approximately 5 years once you get to the Centauri system in order to get information back, or 4.6, because it's 4.6 light years away, and messages travel at the speed of light. So, it could be that at best case scenario, it'll be 45 years until we get pictures and data personally from a whole another star system. And to me, that's amazing, because by that point, it'll be about 200 years since we were just on the Earth, not even flying. And I don't know. That seems really amazing to me. The human race is cool when it can do cool stuff. I've just been destroying this poor Proxima B with planetoids this whole time. Also, the Charon is Pluto's moon. So, if you didn't know that, it's pretty cool. Also, if there are any of you out there who are watching this and believe Pluto is a planet, I'm sorry. It has already been confirmed many times. Pluto is not a planet. It is in the Kuiper Belt, which is in the outer reaches of the solar system, and it is the largest Kuiper Belt object that we know of. But that makes sense because it is the first Kuiper Belt object that we knew of, because it is the biggest. So, also, multiple moons in the solar system are actually larger than Pluto. So, it really doesn't make sense to call Pluto a planet if it is smaller than moons in the solar system. So, sorry about that. Also, Charon is much, much, much bigger compared in ratio scale to Pluto than any other planet, than any other moon is in the solar system to its host planet. So, sorry to break it to you, but that's how it is. Let's see. Where is its age? Man, this planet is stubborn. Alrighty. So, what should we do now? I say we start working with some bigger boys. Alright, so let's find VY Canis Majoris. Hello. And UI Scooty? Scooty? I don't know. Let's just put you right next to each other. Which one's bigger? 6.6 AU, 7.94. Alright, so UI Scooty is actually bigger than VY Canis Majoris. It's interesting. Uh-oh. I feel like they're going to collide very soon. Uh-oh. They're propelling each other farther and farther. Oh boy. I don't know what just happened there, but it appears that UI Scooty just got annihilated by VY Canis Majoris. Alright, let's set your trajectory to your speed to 0. Alrighty. Goodbye. Alright, so let's just put the our little sun next to UI Scooty. Oh. Oh my. The sun orbits very, very fast around VY Canis Majoris. What if we add the solar system? Here we go. Oh no. The sun is in orbit around VY Canis Majoris, which is, and all of our planets are in orbit around the sun. This is not going to go very well for anyone. Oh my. Poor Mercury. Mercury's not having a fun time. Oh, this poor Earth. I want to try this again with a bigger star. Let's see. We've put VY Canis Majoris in, but we put its planets around it. It appears that that will not work. Alrighty. Odd. Let's just delete you. Alright, so let's take a black hole. Maybe this one. Very good. And let's just put the sun around it with all of its boys. Oh my gosh. The sun is just going so fast right now. Actions, add planets. Oh no, Jupiter and Saturn are not having a fun time. But they made a cool design though. They just abandoned the sun. They just booked it out of there. Pluto, Neptune, and Uranus are all gone. Pluto's going toward Neptune, and... Alrighty. So, Jupiter and Saturn are completely ignoring the sun and just going straight around the black hole. The Earth seems to have its own orbit around the black hole. Actually, everything seems to have abandoned the sun and is just orbiting around the black hole. This is interesting. Didn't think this would happen. That would be the same thing as VY Canis Majoris. Huh. What if I just drop this guy right here? This, and this, and this, and this, and this, and this. It appears that they don't care. Alright, what if I just drop a Sagittarius A into your system? Here we go. Now we're getting somewhere. Oh my goodness. Everything is getting pulled up into Sagittarius A. Oh no. This kind of emulates kind of world map. With time going up here and everything swirling around it. If you haven't seen a world map, you should really look it up, because it's very cool. You see, time goes up in one direction, and space is also represented. So, for example, if a planet is orbiting a star, it kind of makes a cylindrical shape, because as time goes on, the planet continues to orbit the star. So, kind of makes a cylinder shape. It's very, very interesting and informative. Also, thank you, New Horizons, for this exquisite picture of Pluto. Looks much better. Before it was just a chunk of rock. Because... Alrighty, so... Oh, bye Pluto. Alright. Let's try this again. Let's pause time. Alright, so... Let's just drop Pluto right here. Oh, no, just kidding. Alright, let's make a new simulation, because I'm trying to see how small Pluto is compared to everything else. Alright, so, this is Pluto compared to Earth. It's very small. it is only 0.00219 Earths. It is only 1.2 thousand kilometers. Earth, by comparison, is obviously one of itself, and 6.3 thousand kilometers in radius. Now, let's compare that to the Moon. Where is the Moon? Good question. There it is. There's the Moon. The Moon is actually bigger than Pluto. And I accidentally started the simulation, so it all got destroyed. Now, let's try this again. Pluto. And where is Charon? There it is. Now, if you look at Pluto compared to Charon, they look rather similar. However, if you compare the Earth and the Moon, you can see a very, very large difference. 1.2 to 6, 6.3 to 1.7. So, it's very different. Let's just, we haven't done a whole lot of just dumb launching, so let's just launch the Earth into Jupiter lots of times. Let's see what happens. Oh, it's heating up, and we're making lots and lots of great spots in it. Not the great spot, mind you, but many great spots. Let's just launch Saturn to the moon a few times. Oh, it looks like those last few Saturns didn't exactly make it. Alright, let's try this again. Oh my. Alright, looks like Jupiter's gone. You know, it seems like when you launch one object into another similarly large object, it doesn't really work out for you. Also, is this one already on fire? Dang. Let's just launch Pluto into it a few times. Alright, this has kind of been a loose kind of video, but I hope you kind of like it, because it was very enjoyable just to launch things into other things. Alright, I'll see you later, Heretics and Heathens. I still don't have an outro, but get out of here.